All right, this is a presentation for group number 44. Our topic is formation and strength of tidal bores, and we will be describing how tidal rise will cause a flow upstream in a river. And we have two presentations beforehand. This one is the Severn bore, and you can see here's the riverbank, and here is the rise of the the tide that's causing a wave to propagate upstream, and it has a large force, and the depth of this wave is higher than the depth of the river, and this will occur whenever we have a shallow river or estuary that is flowing into an ocean, and it will also have other conditions that need to be satisfied, such as large tidal rise and quick tidal rise, which occurs whenever a river is parallel with the rotation of the moon around the Earth. And this occurs in places like Keatang, like Severn, the Severn River, and also in places like the Bay of Fundy. And you can see here that it has a large destructive force, and understanding these tidal bores can be beneficial from an engineering standpoint. So back to our PowerPoint. We hypothesized that using the conservation of momentum and the conservation of mass, we will be able to analyze the strength and the ratio of strength and the velocity that the bore will move upstream. And so the conservation of momentum would describe the tidal flow as it overcomes river flow, and conservation of mass will deal with the flow rate and the as the depth changes. So for our analysis, we used the Frown number, and here we have the velocity of the river initially, which we can measure just any given day, and then we have the propagation upstream, which is denoted by this red dot in the image here, and that we can measure by placing a marker and measuring how fast it moves relative to the riverbank, and then we divide that by the square root of gravity and the depth of the river, which we can measure again at any given time before a bore occurs. And this is an equation from Frown's theorem. Also, the propagation upstream can be calculated by the wavelength divided by the period. So, to find the ratio of the depths between the initial river depth and the depth of the actual bore, we use the conservation of mass, which through experimentation has been calculated as this equation here, where we use the original Frown number using our sample information, and we can calculate our expected depth, D2, of the actual bore. And a bore will occur whenever D2 is, the ratio of D2 and D1 is greater than 1, because the depth will be higher than the original depth of the river, causing a flow upstream. And then the conservation of momentum can utilize the original Frown number to find a second Frown number, and then this ratio, we can take the second Frown number and reapply Frown's theorem to find the velocity of the river upstream as a whole mass flow. And for an example calculation, we have a river that is originally flowing at 0.1 meters per second downstream with a depth of 1.05 meters, and then we have the bore, which will propagate at 3.6 meters per second and moving upstream. So by using conservation of mass, we can find the depth of the bore as 1.23 meters, the velocity upstream as a whole at negative 0.51 meters per second. So, in conclusion, tidal bore is a rise in tide that causes a flow upstream, and as the depth of the bore increases, the velocity will also increase, And we can see this happen whenever the ratio of the depth of the bore and the depth of the river is greater than 1, and that will cause the Frown number to be greater than 1 as well. So, thank you. How long was it?
Like 5 minutes and 15 seconds.
Still playing.
Yeah, you gotta hit the red button.
Yeah.